That's the right level. Set the expectation low when we start. Welcome, everyone. Hopefully in the right room. My name is Robert, and we're going to be talking microservices today. A little, besides the wonderful intro from Lauren. I work at a company called Equal Experts. I normally don't share that because it's not normally important. But today's talk, it is important because I'm sharing what I do. This is an honest look at what I've done for the last sort of 6-8 months. And so it's kind of useful to know that I work at a consultancy and we build stuff for customers who pay us money. And I'm also the steward of DevConf in the developer user group. I don't like the term director. It makes me sound very professional. I prefer the term steward because that's what I do. There are community things. They're for the community, by the community, and I look after that. For those who don't know, DevConf, it's a full-day conference like this. All the talks are selected by the community. We have a whole wide variety. The big difference to this is it's not sort of focused in one area. So you can very much find yourself at a time slot going, there are 5 tracks, and none of this is stuff I do. Which is awesome because that forces you to go off and mingle with people in the network area, or forces you to go off to a room that you might not have ever gone to before. So I'm very proud of this. It'll be our 5th year next year. Please come along. We've got Joburg and Cape Town if you're at either of those. Anyway, let's get to the talk. So today, we're going to be basically doing tech lead therapy. So I'm going to be like, hey, here's all my problems and all the mistakes, and sort of letting it go, and you're all my therapists. Professionally, we call that retrospectives. It's going to be about half the talk. We are going to slap in some cool demos with microservices and some Google stuff for this. It has been a wonderful day. I just want to say congratulations to everyone who's organized this. I've been very jealous of all the machine learning, because I have none in my talk. So at the top, I'm using PowerPoint's machine learning text stuff, because I want machine learning in my talk, too, for extra points. So I have no idea if this will work. Yeah. That's a cool applause for a demo that didn't take long to do. In case you want to know what this talk is, this is sort of intro-level stuff. If you want to run off, you want something more deeper, maybe there's another talk for you. That's welcome. If you want to stay, if you want to go, now's the time. For me, though, I couldn't help myself today. So this is my problem. I didn't charge my mouse yesterday, so that's dead. I need internet at a conference. Live-ish coding, naturally. I was playing with my demo 2 hours ago because I can't help myself. There was asked to be screen recorded, so I installed software I've never used and doing that. And I can't read emails, so this talk is 45 minutes, not 40 minutes, which means Lauren's going to throw stuff at me. So that's the level. So if everything goes off well, I do want an applause at the end, OK? Cool. So let's talk about what the problem domain is. I've been on this project now for about 8 months. We kicked it off with this client. They're a large retailer overseas. I'm not authorized to say their name. And they have a big on-prem system, right? It's built in Java. It's pretty monolithic. And that's a problem, because they have, every time someone wants to make a change, they go in and they make a change, and then they leave and they break somebody else's thing, and there's no clear ownership. There's no clear structure. It's hard to scale. It's powered by Oracle. Scale problem. And they want to change that. They want to move to the modern world. They want to move to microservices so that teams can have ownership. They want to move to feature teams, so teams can have ownership and they know who is responsible. They want to move to DevOps, so that they don't have the problem where it's like dev, write a CR, some other team handles it, it breaks. The usual thing of, we deploy once every 4 or 5 years, instead of, in our team, we deploy every couple of weeks at the most, and faster than that when we're really busy. So this is what the problem domain I got brought into. And the team I'm part of, that I get the privilege of saying I'm a tech lead for, we handle a vertical slice in that, right? So all the way from the front end, which is React, if anybody cares, all the way down through the back end, right to the database level. And this talk is about that. I'm going to show you all the stuff we've done without actually showing you any of the real code, because I'm not allowed to. So one of the things when we kicked off this project is we engaged with what's called the platform team. So platform team's cool because they're a horizontal feature team. So they actually don't have front-end responsibilities or any customer responsibilities. They uplift all the other teams. And this has been, for me, one of the greatest things to work with, because having a team that you can go to and go, how should we build this, really helps. And they focus on that. And it's a bit expensive for the company to kind of have this team that just builds internal stuff that doesn't really directly make money, but it really is powerful. And so we started engaging with them, and they came to us and said, hey, like, we've got some guidance for you. You don't have to use our guidance. You don't have to use what we built, because you're all adults, and you can make good decisions. But if you use our stuff, it might help. So obviously, they said, like, our cloud provider of choice is GCP, to which I said, that's OK. Then they said, hey, the next thing is, we'd like you to build everything with Docker and Kubernetes. To which I said, oh, not more YAML. And then went, can't I just do serverless, please? And I really wanted to do serverless for this. I kind of feel like, while Docker and Kubernetes is the now, and very much the now, serverless is the future. And I thought we could get smaller things out. And really, the application doesn't have that level of complexity. I need long-running stuff in containers. The first big decision we made was actually to agree to go that route. So we actually diverged from what I wanted, which was serverless, to going Docker and Kubernetes. But as a team, we made the call to say, hey, whatever tech we choose has to be future-proof, right? We don't want to pick something that's not going to be great in serverless, because we will change at some point. Change is totally inevitable. So we have to pick something. So it kept it in our mind. Once we accepted their Docker and Kubernetes stuff, they gave us a bunch of quick start guidance and getting up and running in the environment, gave us cool stuff that we got like out-the-box monitoring for our containers. And they also said, like, hey, you should probably be on the JVM stack, which we said, cool, like no problem there. And then we sat around and said, so what language can we use? And they went, that's up to you. I'm like, oh, you've told us all this good advice before, now you don't have any opinions? So PJ, who was in here earlier, for anyone who was at his talk, it's all his fault that I use Kotlin now, because I went to his talk at DevConf. It's not a plug, it's absolutely true. And he did a talk on what is Kotlin, and I love Kotlin so much because it's so easy to get started with. I was listening to Carla's talk upstairs, and she was like, I don't want to go into Kotlin yet. It's too complicated. And I was like, almost ready to like throw something like, it's easier than Flutter. Have you seen how much you write? Like, look, you write really little. Terse code. So that was a decision. And then we had to pick a framework. So we looked around. We asked the other teams who were there, because it's always a good idea to ask everyone else. And we found the usual candidates, right? There was Spring Boot, and there was Dropwizard. And there was one team using Micronaut. So we took all three of them, we looked through them, and we picked Micronaut. So what is Micronaut? So Micronaut is a new framework, like 2018 first release new, which is kind of weird, right? Like I haven't got to play with this sort of newish stuff that often. It feels like I'm in JavaScript land again, where every week you get a new framework. And it's from the people who bought you Grails, so it's got good support for like all the Grails stuff. But when they were building this, the reason they built this is they said, like, hey, Grails is awesome, Grails is fun. What if we started it again? Like, what if we said, hey, this Grails stuff, if we built this today, and we take advantage of all the cool new things we have today, and all the new ways of thinking we have today, and all the new advantages of languages like Kotlin, what can we build? And what can we build if we start building for the business problem or the tech problems that people have today? So one of their goals was to build for serverless, right? Because if you can build it and it runs really well in serverless, then it will run really well in Docker and Kubernetes, and it will run really well when you have it on-prem, right? And so they went through this. And they thought about this, and as the last line there says, they embraced open source and got a lot of good ideas. So that was a joke. Like, that last line doesn't say that. Oh, wow, need more coffee. Right, so I don't have many jokes. I have to cut all my good jokes out of this. You've got to laugh at least the ones I was allowed to leave in for time. I'm going to start to compare Micronaut to Dropwizard in particular, maybe a bit of Spring. Please understand, I'm not saying those frameworks are bad. The rule here is, does it work for you? Yes, it's a good choice, right? There is nothing wrong with that. I'm also going to talk about performance as a way of explaining what's different in Micronaut, okay? It's just a framing device. It's not a way of saying, hey, because these frameworks are not as fast, therefore they are bad. That's totally not what I'm saying. Your usage of it today is good usage. And also, I'm not saying that Foster is the important mechanism. We actually didn't pick performance. It wasn't an important decision for us. But it's a nice way to talk about Micronaut. So if you are thinking like, hey, Robert says, do the performance stuff, like that's not what I'm saying at all. So here is a chart. We ran this using Gatling, which is our preferred load testing tool. Super easy to get started with if you've never had a load testing tool. This is cold start performance against a drop wizard service. And it's got the traditional problem, right? Really bad performance at the start for a bit while everything gets cached, and then really better performance after time. That's OK when you are on a Docker image or anywhere else, because you can do things like warm-up scripts and things to speed that up so that first hit isn't too terrible. But it's not great when you're in serverless, because when you're in serverless, that first hit is probably starting everything from scratch. So you can't have this thing take, like here, over 4 seconds. Like, that's just not reasonable. You have to have things go faster. So how does Micronaut go to that? So this is from their launch slides for Micronaut. And this is what their goals were. Now, I'm still not sure why having the smallest jar is important. I've tried to figure this out, and I cannot. But it's cool. Like, hey, we got a small jar. What's really cool is their performance things, right? 10 megs of memory. That fits really nicely into serverless, right? Especially when you're in cloud, right? If you're in GCP or AWS or Azure, you pay for this stuff. You pay for CPU, you pay for memory, you pay for processing time. Cutting down memory is a good thing. Startup time of sub-seconds, right? Now, there are some tweaks to get that. And that's not just straight out the box on Java 11, OpenJDK. That's not going to happen. But you can totally get it to sub-second from total cold to the service running up and running, and then have your first request handled within a second. That's awesome. So I like this slide because it's just like, these are crazy numbers. So how did they do that? So as an example, if you look at something like Spring, they use a lot of reflection, right? So you have API controller, and you'll do a request. Hey, get cart. And what happens behind the scenes? Okay. Hey, get me all the list of the methods, find the ones that match in XML, drop wizard, load up all the stuff into memory, loop over the methods, find all the attributes, loop, 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 find these things. And that's why you get performance after a time. So that first time's expensive, but then that all gets cached in memory, and that goes really quick. It's all getting cached in memory. That's why your memory usage can't be 10 megs, right? And so that's kind of how they do it. And all this happens at runtime. That's the key here. So how does Micronaut do it? So I'm going to change the slide in 3 seconds, and you can see if you can spot the difference. The only thing that changes is that this all happens compile time now. So yes, you pay more on compile. That's OK. I need reasons to play games on my phone. So what are you doing? Compiling. OK, it's done. So a compiler does it. So this all happens pre. When you hit it, boom, much better performance. Okay? So this is called ahead of time compilation. It's really, really awesome. What else does Micronaut have? It has really one of the best dependency injection frameworks I've ever used. It just works, is kind of the best I can say about it. I come from a long history with Microsoft and .NET. Nothing they have is close to this. I have not found anything in Java that's close to this. It is beautiful. Because it's built for the current and the future, everything you want is kind of in the box, and I'll talk about that just now. But if you're building microservices, even if you're building modern services and you want to talk to your Prometheuses and things like that, it's all there. And most of the time, it takes one line of config change in your build Gradle to enable it, right? So it's really simple. And lastly, really reasonable initial configs. So you can enable something, and once it's enabled, it kind of works the way you think it should. You can always go change config if you want to, but most of the time, we actually haven't had to do as much config as we have had to do with drop wizard while I get attacked by a bee or a fly. So with that, let's do some live demo-ish stuff. And we're going to build a microservice. Since I feel like I'm ahead of time a little bit, this thing here, I'm using a laser pointer, that's a moo. It's a cool scientific notation for micro. And it's way faster to type out micro, but it's way cooler to spend 10 seconds looking in the emojis for that. So how did I get to, before we get to the demo, this was me on my machine a couple weeks ago. Click. You start off with, they've got a Micronaut CLI tool. CLI tools are awesome for demos, right? So I type Micronaut, create app, language Kotlin, please, and build it in place. So build it in the folder I want. That will generate everything I need. Then I said, hey, go create me a controller called the games, because I want to build a little video game database for this demo. and then do a build, right? Edit the build because it was missing a dependency for some test stuff. And then Gradle build, done. So that takes us to the demo. Let's go find some code. Right, so here is where we end up with that. Okay? If you are familiar with JAX-RS, this should feel very familiar. Okay? This is not JAX-RS at all. It's their own annotation stuff, but it's very much inspired by that. And you can see here, this is the controller for games. And when you do a get to /, it's going to give you an OK response. And we will check if this is running. Cool. So I've got my awesome Gradle running here. And we can go to Postman. And so this will do get to there. And we can send it. Sending. Cool. And that did a 200. And there's nothing in the body, right? Really simple. I'm glad no one's applauding for me, my pre-baked demo. That was like, whew. So how can we build a games database? So let's start off with a bit of cool Kotlin code here. I'm going to bring this across. Because I'm worried about time, we are going to sort of copy-paste a lot. So this here, come back here. So this here, actually, quick hands up. Who here knows Kotlin? See how much I need to go into this. Cool, not many. Right, let's talk about this. So who likes lots of boilerplate code in Java? Nobody. So this in Java, this would create a class, as you would expect. It's got class there, right? The bit after the name there, that's the constructor. It's called a default constructor, and it's taking in a name, which is a string, and a year, which is an int, right? It's got val in front of them for value. They're read-only. They become properties. So it's a constructor. It's set to my properties. I also have another val in there. That's also a public property. It's got only a getter because it gets its value set up, and it gets an initialized value. And the data there, that creates all my toStrings, and my hash codes, and everything. That's a whole class. It's perfect. This is why I like Kotlin, because that is like infinite number of things in Java to do. Also, you can have multiple classes and things in one file. Kotlin doesn't care. It's not Java. So let's go and make use of this now. We'll replace our body here. And you can see I've got my professional database there. That's how we build stuff in the real world. Everything in memory. No, I'm kidding. But what I have changed is I've changed the return type here, right? So previously that was any. So I could return anything, and that's fine. Here I have gone and put it as, hey, I want to return a list of games. So that's pretty cool. Oh, I should have hit save first. So I have configured my compiler here, my setup, that every time I change a file, it will detect that and restart. And it'll give it a second to restart, or recompile. So because obviously the ahead of time compilation, you have these sort of little bit of slow times there. Cool. So now if we go in here, what we're going to look for when I run this is, wrong key. Instead of having an empty body, we're going to have an empty array, right? So let's do that. Send. Push. There we go. Empty array. Cool. Aww. Pity clap. Thank you, Zanti. Oh, yeah, you're too kind. You're way too kind. Right. Note, I don't have to do any JSON stuff. I don't have to do any of that magic. Like, it just works because obviously it should. I don't want to be spending my life writing this code. I want to get stuck into the real problems. Figuring out how to get a talk about machine learning for next year, I guess. Cool. So that's simple, right? Like, happy? Everyone cool? Nice and easy. So let's take this a step further. So I'm going to dump in a bunch of code here, and we can talk through this. So this is now filling it up, right? So we've got a bunch of more interesting things in here. Right, how do I handle post? Hopefully you kind of could have guessed this. I just have a post attribute, okay? And that will like let me post to it. Now, note that I've got string name and year in there as parameters, okay? I haven't told Micronaut where to get those from. So Micronaut, by default, will let me pass it in as headers, or in the body, or in the query string. And if I wanted to constrain that, I could just put more attributes on that. Micronaut's really big into attributes because, ahead of time compilation, you can take that and change it. So we'll have that in there. You'll see then we add it to our database, return an ID. There's a delete. Let's scroll this down. So the get, we're going to have a get item. Now, I know this is not really what I do. I'm not building a games database for this big retailer. That would be way too interesting. I'm a consultant. They give me the fun jobs. But I'm not joking when I say this is really a lot of what we do, right? A lot of what I do and have always done, which is quite sad, is to build forms over database apps, right? So there's a form, React database, nah. It's just the tech that changes. And for us, this is really a lot of this. We have a few more methods, but that's really all we do. So that's there. Did I hit save? I can't remember. So that's going to do all its cool pre-compilation. While that does that, I just wanted to remind you, Kotlin does say like, sub-second startup times. So I'll just fix that so my demos are right. Yeah, talk to me later if you want to know how to get sub-second performance times. Cool. So we'll hit send on this. Just make sure everything works. Okay, that's my worries in life. I've got a pre-built post here. And you'll see it's going to post, and I've gone and set up a body. Cool. I'm going to pass this in as a nice JSON blob, right? Because that's what works for me. Though I don't want to do Doom, because that's not cool. I want to do Game of the Year stuff here. There we go. If you're not playing Outer Worlds, that's what you have to do tomorrow. Cool, so I posted that, right? Boom, status 201, yeah. And nothing in the body, but we should have a location in the header for where our item is, which is quite cool. We can go back here, hit get, spin, spin, spin. Hey, look at that. Some cool stuff there, and we can fiddle with that as we want to. So that's pretty cool. Let's see, next on this. So how about like we're going to make this like enterprise-y level? We need to add some authentication, right? Because, we can't just have everyone editing what games are in a database. So I'm going to add a filter. Look at this. Ooh. And if you understand this code today, come back here. Thank you. If you can understand this piece of code, this is the single hardest piece of code we have. It's very similar to what we have in actual production, except instead of like hard-coded values, we actually go and look up your user. We try for security like everyone should. But this is really it, right? So we start off there, line 15. Hey, go find the username header, right? If there is no header available, immediately return with unauthorized. Boom, done, thanks, right? Otherwise, put the user ID, the username, into a property called user ID in something called the request attributes. Okay? And I'll talk about request attributes in a moment, and then continue on. So you can have multiple filters, right? And I promise you, this is as hard as this gets. If you can understand this, you are totally at the right level to come work with me. You are officially now a Micronaut developer as well as a Kotlin developer. I say that. My DL's over there, so you can bug him to come and work with us. It'll be awesome. We'll have a great time. I can't remember if I copied and pasted this, but we'll copy-paste it again. Right, so this is how our code changes now. So note, hey, no. Let's grab get. So remember I said we had that user ID, right? And we passed that in. Now we have a thing called attribute, request attribute, and user ID. How does it know that user ID matches the one I want? Because of names. Because I called the one user ID, and it goes, well, you've put this thing into our internal store as user ID, and if you name it user ID somewhere else, it's probably the same thing, right? And it's this convention over having to configuration that makes Micronaut so powerful. I can't, there are other frameworks, Spring, who wouldn't make me write 9,000 lines of XML for that. Like, this is so much nicer, okay? So we have that in there. And we can go and put that all on there. The other change I did on this one is I've also just gone and added an owner to our game thing so that when we do add it to our database, it all works well. So that should have restarted by now. I'm just going to close my eyes and hope it works. Ooh, there we go. Look at that. 401 unauthorized, right? Because I didn't pass anything in. Boom, real security. OK, let's go add in a header, username Tim. And we can do send again. Boom, Tim has no games. Tim's life is bad. Let's go to our send. Username here is also Tim. Send. Go back across here. And we can do a get. Spin, spin, spin. Hey, there's the game for Tim, which is awesome. And if we change this, I'm going to try and kiss up to Lauren so she doesn't kick me off stage early. Resend that. Lauren has no games. Cool. So that's kind of how we make a microservice. And that really is how we make a microservice. But I'd like to remind you that all demos you see on stage are like Portal video games. The cake's a lie, the demo's a lie, right? I've never done MN create controller. I had no idea you could create controllers from the command line until I prepped this demo a month ago. Like, that was like, oh, whoa! This would have saved me all of like 3 seconds creating file in IntelliJ. What the? OK, so we never do that. We also did everything in interfaces. All the attributes we actually pulled out into an interface, which is great. The reason we did that, so you saw that like we had the @gets and all that. It wasn't a lot. We needed to support Swagger. So Micronaut supports Swagger through attributes. So every method had like 30 attributes above it for like, here's all the exceptions, here's all the messages, here's the description, all of that glorious stuff. And so what we did was to go, OK, right-click, extract an interface. We had an interface with all the attributes on it. And then our actual code is just pretty nice and clean. So that's slight differences there. In terms of things we didn't like as a team, I don't like the HTTP client. It feels just like DropWizard's one, and I don't like DropWizard's one. I recommend using Java 11's one. It's much better. One of the complaints for some of our team members who come from, and this actually, funny enough, come from a background with DropWizard, is it felt like magic. These things just work. Like you call it username, there, user ID there, and you call it user ID here, and then they link, right? You have these, like, there's no config. There's no hidden config file that I've set up for this demo, right? Like, there's no XML. It just works. In fact, let me run across back here to show you the other cool thing. I like messing with the sound guys. They have to hear me running and slapping myself and things like that. So sorry. That's the startup, right? Literally, you have seen every line of code in this project now, OK? The complaint was that it felt like magic. It does. I don't have an answer to it. I just accept it. It's also a year old, so documentation is hit and miss. It's pretty complete for some pieces and pretty meh for others. They have a lot of guides as well, which are probably better than the actual documentation, so you go read the guides. Yeah, it's a thing. If that's a big problem for you, maybe not for you. Some other wins for this. We have what we call the put of success. This is the first time I've ever had to work with Stackdriver. I wanted to output stuff into Stackdriver. It was one change in a build Gradle file. Done. Perfectly set up. Prometheus. We need to output Prometheus metrics, right? One change in a build Gradle file added the /Prometheus endpoint for us. It was also part of properly secured, so you had to be local to get to it, which worked for our configuration. So it wasn't available on the internet. We didn't have to think about it. We didn't have to spend time trying to figure out how to do it. It was just there, which is awesome. We have yet to find something that you can't do with it. So if you are working with Droppers or Spring or anything else, it has all the stuff that you can think of. And lastly, we have what's called the escape hatches. There are times where you want to do something a bit crazy, as we did. We wanted to have low-level access to the HTTP requests for one scenario, and what we returned instead, and we could totally get to it. I've never had this level of freedom in a framework. I can go all the way down pretty much to the JVM level, get all the lowest level bytes, and just fiddle with it if I wanted to. Hopefully you don't have to use escape hatches, but they're there if you want to. So we didn't have a good database in that. I think you would agree. So cool. What about database? So we picked 10 minutes. That's not fair. Messing with me now. We picked Data Store from Google for this. And we sat down and grabbed the blessed Google APK for the SDK for this. And then we all cried silently inside because it was a bit crap. Because we don't want to use strings, right? Like, I don't want to have all these strings. I want to work with objects. I want to work at this high level and be like, ooh, put things together. And so we didn't like that. And we actually fiddled around and played with different frameworks. And we ended up with picking Objectify. Ooh, let me go. Let's go back through all my slides. So the world's cheesiest Objectify demo. So I had to slide back to that. Let's go in my snippets. Right. Let's dump this in. Boom. OK, so this is all what it would look like if we added Objectify. I'll start with the game class. You see we've added an entity onto this, right? That tells Objectify this is an entity. And then the only other thing we've done is we've inherited from a new class we created. And that class gives us, hey, move our ID into here so that everything we use has the same ID. We prefix it with ID so that Google's data store knows it's an ID field and we can do lookups against it. We created some more fields, and these would be fields in the database. We have an on-save, so every time you save an item, it updates the modified date. Cool. There's a little bit of Objectify tax you have to pay, which is this. So every time you start up your application, you have to do this. You initialize the service. Then on line 67, because we're working with date times, we register JODA so that we can do the translations backwards and forwards. On line 69, we register the class. So we say this class game will be a table in our database, and then we start the service. And then we get off to like what the code looks like. So how would we, get a game? So this is how we get a game, right? Objectify.load things of the game type with the ID field of I am passing that and now, because I want this to be synchronous for this demo. Objectify fully supports asynchronous, and so does Micronaut, which is beautiful. So you can actually go and build like services that are not I/O bound, so that can handle more load if you are worried about load. So that's how you get something with an ID. How do I get something with a game, like filtering? So same thing, Objectify, load, type, game, filter. Ooh, my zooming is not updating the screen naturally. Let's do that. Come back here. We'll zoom in there, right? Filter, give me the owner name, match to user ID, and then give me a list of that. This piece here is not Objectify. This is Kotlin, right? This is a game class, ... So class, property, give me the name of the property, which is always the same thing, but it gives it to you as a string. I had a moment of absolute joy because we didn't write it this way initially. We actually just put in a string called owner. And when I realized we could do this, it made me so happy because it meant if I change anything in my models, it will break everywhere or update everywhere. I can use refactoring in IntelliJ to go and rename, and it saves me so much time. It doesn't matter if you don't use Micronaut. That's an awesome little thing. So that's how we get a list of things and how we update. We create a new instance, and you just call save on it, right? That's as hard as it gets. It's really nice and simple. Big fan of it. Right. So wins, losses, lies. We moved all our database stuff out into a separate library. This is not great with Micronaut. Micronaut has a thing called import tax, and it gets really annoying. Don't tell anyone. Drew, close your eyes. I'm not showing real code. This is real company code. Okay. This is how you import code from other libraries into Micronaut's dependency injection system. This is annoying. You write it once, you never think about it again, but you do have to kind of do this. So we're importing these functions, list action specific for migration, into these other functions, and we use a factory to load that up, and then we can pass that factory around. So that's kind of the most painful part of that. It was awesome we didn't have to worry about strings, and it was great that we could support sync and async because that gave us the ability to choose what is right for the use case at the time, not be stuck to what the framework told me. So let's get on to some infrastructure pieces because, I mentioned at the start, this is all Kubernetes and Docker, right? So this is what our architecture looks like when drawn in PowerPoint. We have some cloud, you hit a gateway. That goes off into various Kubernetes namespaces. There's a cart namespace and a products namespace, and then they're all subdivided. And then we have pods, and then that's where I spend some time. Like I'm going to work on the pods and the Dockers, and I have to write some Docker config, which looks like this. And then that just makes me sort of start twitching because it feels like I'm writing config.sys. See old people laughing over there? You kids are too young for that. And then I start to get annoyed because it's a different language and I don't know it and I just want to work in Kotlin. So I go and Google memes because as a tech lead, my coping strategy is anxiety or memes. So probably better to do memes. And all I want to do in life is Kotlin, right? I just want to write some Kotlin. Why do I have to write Docker? So there's a solution to this finally. Jib. Jib's my favorite thing. So let's go across to here and kill this. So what I have also configured is everything's a lie. Build Gradle, I added this in, right? One line into plugins. Jib is a component from Google, added in there. I also added in this line. I'll talk about this in a moment, but so you know it's there, right? And now I want to make a Docker, right? So all I have to do is do Gradle, w, gib build to tar, well, build tar, right? If I've spelled everything right, this will kick off in a moment, and this will create a Docker image. There's no Docker config, there's no Docker file. It is creating a Docker image that knows what Java is and how to start up applications, right? It is awesome. And so it will build it and create a jar on my machine, eventually. Come on, you've got to go faster than this. Thank you. Right? So that created a jar on my machine, and I can now go and take said jar, put it in said container registry, and make things happen. But it'd be cooler if I didn't have to, right? Because that's not the default. This is the default. Right? So if I tell it just gib, what it'll do is do the same thing. It's going to eventually wake up and start to build. And it's going to build my stuff. And then, because I put that one line in my config to say, I want to use GCR as my container registry, it will then actually take it and start uploading it. Now, I'm doing GCR because look where we are. But if you want to use this with Amazon stuff or Azure stuff or Docker Hub or your own local thing, you are totally empowered to do that. And so if that all worked right, here's our container registry. You can see how many times I've been practicing the demo. Probably not enough. OK. And we'll hit refresh. And this is the last demo, so hopefully it goes well, because I haven't had any other mistakes. Don't die on me, Google. There we go. There we go. That's awesome. I like that. Thank you for the claps. I didn't have to do much for that. You guys clap for all the simple stuff that I don't have to type lots. Lots of typing ones, you guys don't give me any love. I don't know what's with that. So yeah, lies about gib. We did that months ago. It's in our GitLab pipeline. It does it. I never see it anymore. We also do scanning of items on GCR. It's really worth doing that. If you don't do that now, costs a little bit extra, but you get really good reports of, hey, this dependency and this thing is all broken, and you need to update because you're going to get hacked. Gib wins. So obviously it supports everything, but also has a thing called gib core, which is a library that they've encapsulated all this logic that you can then use and build your own projects out of, which means you can build projects that build Docker containers. So if you need to support other build tools or things like that, you can. Or if you want to build some really crazy AI that takes over the world by infecting Docker Hub, you could do that as well. Right. Other odds and ends before we end this off. Testing. I didn't cover that. Lessons learned. Run all your tests all the time. We went with the approach of, all our tests are good, but our load tests, they take too long. We'll leave that until the end. And we'll just run that before we deploy to production, right? That went wrong every time, right? Run all your tests all the time. Get good build pipelines. It saved us a lot. Mock sparingly. We have definitely over-indexed on mocking, especially with WireMock. We've mocked everything out in the back ends. I spend more time trying to fix WireMock for my unit tests now than I do unit testing. Pick your battles there. Lastly, we had to build a CLI tool to do some data transfer stuff. And I wanted to have cool parameters. I wanted to be able to run a command, then do -- bucket name, pass in a bucket name. And I also would prefer to put that in a Docker image and then use environmental variables to set that instead of me hard coding strings. So we use a framework called Clicked. It's a really great way to build CLI tools if you're looking for one. It makes working with parameters and things very easy. So wrapping up, since I have 1 minute. Micronaut, we're really happy with it. It served us really well. It's really great knowing that while we run on Kubernetes and Docker today, when we switch to going to serverless in the future, it will be quite pleasant. My advice, though, is if you are in whatever you're using today, that's good. Keep using it. Don't feel like you have to jump to it. But if you'd like to experiment, there are things like Micronaut for Spring, where you can start building new things in Micronaut and have them imported into Spring naturally, which means you can start to sort of chip away at the work and get you there. And lastly, because we all want to make those sweet, sweet SRE salaries, just get gib and now put in your CV that you're an SRE, right? Cool. Well, And that's it. Slides, all the code, everything's up on my website if you'd like it. And thank you so much.